Section 4. Dualist or classical dash. Only alternatives ? Max Wellman notes the Copenhagen School claim that the conscious act of observation collapses the Schrödinger wave equation. He then concludes that this position constitutes a form of dualist interactionism. As previously, in terms of a philosophical label, I prefer the term dual aspect monism. According to him, however, this suffers from the same serious problems that beset macroscopic accounts. Wellman concedes that quantum effects occur within the brain at the microcosmic level, just as they do in the rest of the material world. But there is little evidence as yet that these have measurable macrocosmic effects, nor is it clear how perturbations at the microcosmic level could be translated into psychologically relevant macro effects. Solving a problem or speaking a language, for example, seems to require the manipulation of symbols grounded in meanings, which can be related to global knowledge of the world. It is by no means clear how such operations on representations of the world could be determined by some non-material consciousness, momentarily affecting quantum mechanical events. Events at the quantum level do not determine the way conventional computers operate on representations. Wellman concedes that the brain may turn out to be a quantum computer, but otherwise, he concludes, quantum is at the wrong level of explanation to provide an explanation for consciousness. In dismissing quantum consciousness, Dennett starts by briefly surveying the history of efforts to substitute an immaterial mind or a soul for the modern notion of the mind as mechanical, ranging from Descartes to John Searle. As Dennett points out, Searle states that the brain is not an ordinary computer. It has causal powers that go beyond the running of any algorithms. Searle has not been very forthcoming about what special powers these might be, or which of the physical sciences might be the right one to give an account of them. But others have wondered whether physics might not hold the key. As Dennett puts this, quantum physics to the rescue. Several different proposals have been advanced over the years about how quantum effects might be harnessed to give the brain special powers beyond those of any ordinary computer. J.R. Lucas, 1970, yearned to drag quantum physics into this arena, but he thought that the indeterminacy gaps of quantum physics would permit a Cartesian spirit to intercede, twiddling the neurons in effect to get some extra mind power out of the brain. A doctrine that has also been energetically defended by Sir John Eccles, the Nobel laureate neurophysiologist, who has scandalized his colleagues for years with his unabashed dualism. Here and elsewhere, Dennett makes clear his anathema for dualism, which he seems to equate without exception to Cartesianism. Later, we will look at how fundamentally quantum dualism differs from that of Descartes. In dismissing the notion of a quantum explanation for consciousness, Vellmans makes three assumptions about quantum physics, which I believe the quantum physicist Henry Stapp would disagree with. Vellmans says firstly that quantum physics retains the classical notion of physical closure. Vellmans says even an account of brain activity that incorporated quantum effects would not alter the fact that the physical world is causally closed. Secondly, Vellmans seems to claim that not just the Schrödinger wave equation, but also its collapse are deterministic. He says, any momentary biasing of probabilities by conscious free will would have to be compensated for by subsequent biasing against those probabilities. Otherwise, the shape of the probability function would be changed. Thirdly, he claims that the Copenhagen School's requirement that the consciousness of an external observer is necessary to collapse the wave function of a quantum mechanical state is paradoxical. Not just in terms of physics, where the paradoxes have been much discussed, but in terms of the processes involved in perception. Visual perception is extremely sensitive. Under optimal conditions, only 5 to 8 photons are required to trigger a visual experience. However, consciousness of input stimuli takes time to develop. Experiments reviewed by Libet 1996, for example, suggest that it takes at least 200 milliseconds for neuronal states adequate to support a conscious experience to form. In short, consciousness of an external event takes place later in time than the event itself. If so, how could the resulting conscious experience affect its prior cause? This would seem to require backward causation in time. We'll specifically challenge all of these statements in later units. Vellman insists that the central problem for dualist, including quantum, accounts of causality remains the phenomenology of consciousness. He quotes Eccles to the effect that the self-conscious mind controls activities in the motor cortex through the exercise of free will. But, he asks, how could a consciously experienced wish to do something activate neurons or move muscles? The processes required to activate neurons are not even represented in consciousness. For example, the phenomenology of a wish includes no details of where our motor neurons are located, let alone how to activate them. The same argument applies to the quantum mechanical level. Experiencing a wish reveals nothing of the momentary probabilities of quantum mechanical states, let alone how to alter them. Consciousness without phenomenology is not consciousness at all. Consequently, if some aspect of the mind does control the momentary activities of neurons, that aspect of the mind must be non-conscious. This argument has many implications as to exactly how consciousness within a quantum dual aspect monism should be defined. We'll look at this in later units. Hodgson summarizes what he calls the consensus view in the study of mind and consciousness. This consensus view is distinctly opposed to any notion of quantum processes being involved in consciousness. He says that, notwithstanding quantum physics, the physical states and events of a brain immediately after a conscious decision is made can in principle be given a correct and maximal explanation in terms of the physical states and events of the brain immediately before such a decision, and in terms of the operation of physical laws. This explanation may not be complete because at the micro level, physical laws give only probabilities. However, at the macro level, these probabilities produce near certainties, and insofar as they do not, what occurs is a matter of pure chance. Certainly, reference to the conscious decision could not complete the explanation insofar as it is incomplete. Let's note here that one of the main planks of this defense against quantum influence on the brain-mind is the insistence that a clear and unequivocal boundary exists between the micro-quantum realm and the macro-classical realm. The consensus view further insists that all brain events are located firmly on the macro-classical side of this boundary and are therefore safe from quantum influence. This question as to whether or not there is a definable boundary between the realms of quantum and classical physics is key to the issue of quantum influence on mind and consciousness. As above, promoting the notion of this boundary is a tactic often employed by physicalist researchers to justify basing neuroscience exclusively on classical physics. They suggest that once neural activity reaches a classically describable level, for example, the firing of a neuron, triggering an action potential, one can assume that the quantum jump from potential to actual has occurred, and that consequently one can deal simply with the actualities of neuron firings and ignore their quantum underpinnings. Stapp responds to this by claiming that such an approach would be a misuse of the quantum mechanical use of the concepts of classical mechanics. The founders of quantum mechanics were very clear about the use in the theory of observations of the concepts of classical mechanics. Those concepts were needed and used in order to communicate to others what we have done and what we have learned. The use of the classical concepts is appropriate in that context because those pertinent experiences are actually describable in terms of the classical concepts, not because something was mysteriously supposed to actually happen merely when things became big enough for classical ideas to make sense. That criterion was too vague and ambiguous to be used to construct a satisfactory physical theory. The boundary between the large and the small could be shifted at will within limits, but actuality cannot be shifted in this way. In other words, Stapp is denying the existence of a meaningful boundary between quantum and classical physics.